topic is classroom culture, teacher beliefs, learner beliefs. I've recently rediscovered the book called The Teaching Gap by Stigler and Hebert, where they make the point that teaching is a cultural activity. I decided to let this chapter just hang there for a moment. You can browse, because this concept of what is a cultural activity, they're making the point that the family dinner is a cultural activity. That means that everybody knows how it works. You learn it from your mother from a very young age. Everybody knows what to expect. Everybody knows what to do. Okay. The point is, and my point will be, that teaching and teacher education is likewise a cultural activity, which here at the bottom they say, we learn implicitly through observation and participation, and not necessarily by deliberate study as such. Another article that they wrote, I just want to quote a small little bit. Everybody is saying, Kuno also said, there's just about no real, permanent, great innovations. Can't succeed without changes. Okay. They say, well, if it is a cultural activity, it is to be expected that it will be near impossible to change. Right? Because teachers reproduce the classroom scene they know since their childhood, they're comfortable with it, it comes automatically. We all have this view of exactly how the math classroom looks and what happens there. And what we're talking about is we want to make changes, then that is the very thing that must be changed, because if that thing does not change, nothing else will ever change. Okay, my thesis basically is that the problem with innovation, etc., can be blamed on this teaching as a cultural activity, the classroom mathematical culture. So I will briefly make the point that what learners learn is determined just as much by other non-cognitive factors as intellectual and cognitive factors. And those factors, in a broad sweep, is learners' beliefs about mathematics. What is mathematics? Learners' beliefs about how do you learn mathematics. Learners' beliefs about what's the role of the teacher, and learners' views of themselves. And the point here is that those beliefs are largely structured and determined by our classroom mathematical structure. Of course, also others, parents, society. And we'll make the point that, on the other hand, the teacher's beliefs about exactly the mathematics and the learning and the teaching and the learners influence the mathematical culture in the classroom. I'll talk later about getting feedback from learners learning. That I will basically be talking on this underlying ideas about the beliefs. I got this from our local Afrikaans newspaper. Every year when school opens, they got a photo like this from grade 1's, Sabay's out. And I tried, but I just cannot translate the Afrikaans. Weetgierige haasbekkies nie. So I leave it there, inquisitive, toothless swans, or something like that. But I say, this is the tragedy for me, for us, namely that the inquisitiveness, the enthusiasm, the engagement of our children's early years fade away quickly and is replaced by a strong belief that math is all about following instructions and rules. And the question is how and why, because it's exactly those beliefs that now influence their interest, their engagement, their involvement, and their marks in mathematics. Okay. Alan Schoenfeld is talking about renewal, about relevance, new math problem solving, says those reforms reflect an attempt to embed a selected aspect of mathematical thinking into what is essentially an alien culture, that of the traditional classroom. As long as the two cultures differ as radically, it may be impossible to embed it. You know, it's like when you do a transplant, the body wants to reject it. Not so. You need strong medicine so that the body will not reject the transplant. And that is exactly that. We come here with transplant ideas about problem solving or relevance or themes or something that is now going to change and save mathematics education. They cannot make a dent in the traditional classroom with its norms as such. I think I wanted to say something now about that feedback. I call that the self-fulfilling belief that is reinforced. Because you see what happens, and we'll unpack it more now, is that, okay, so the teacher says, he's now going to try these new things, so we'll try. Now he goes into the normal classroom. I'll show another slide on the same idea. Into the normal classroom, and now suddenly expects children to investigate and discover and construct new ideas when they've never done it before, because what happens in that class is they sit and wait for the teacher to show them. Now, where will they now suddenly get the willingness or the expertise to do anything more than that? And so they fail. And so the teacher says, I told you so. Self-fulfilling beliefs. So it reinforces our beliefs. Unfortunately, often negative beliefs. I wanted to bypass it, but I just have to briefly just mention the didactical contract, which underlies this, which comes from the French, from Rousseau, etc. And the didactical contract is the unwritten expectations and obligations of teachers and learners, determining the daily classroom rituals, what happens, how it happens, etc. Kuno had actually a very positive description there of one. I took the negative one here, where in the traditional classroom, the teacher does not expect learners to be able to do anything he did not first show them. He undertakes to show them. He expects the learners to learn it. And conversely, the learners do not expect it. Teacher will expect him to do something that he didn't first show them, etc. Now, that then determines the classroom culture. Now, we must do something radical if we want to get something more done. It is a different language. I decided not to go there, where Kuno stressed the social norms, social mathematical norms, etc. These are the things at stake. I mentioned, let me just, here I'll say something about learners' beliefs about the self, because this is big news currently. and we all know about it, so I'm just mentioning it without wanting to do it, although it's very important. Namely, the idea of a mastery orientation versus performance orientation. That means wanting to learn the content versus competition. And then we all know about Caroline Dweck's growth mindset and fixed mindset. So we should obviously all be trying to use these ideas to improve our classroom mathematical culture. Teachers should promote the mastery orientation, the growth mindset. We could talk of how to do that. You guys know it's not so simple just to praise learners, for example, etc. Pose challenging tasks, encourage learners to engage and to persist. Again, that's not so easy because the research over many years shows that if children is in a performance orientation, they're less inclined to wanting to persist and to try. While children who has a mastery orientation are more open and willing to take chances and to work on some unknown. Emphasize the connections between persistence and learning. These are big issues, they are important issues. But I do not say anything more about them except to quite a long quote. It comes from Jeannie Oakes. If you know anything about Jeannie Oakes, you will know that she uncovered this whole problem with tracking and streaming in the United States. And that ever since the 1970s, yeah, there was this de-tracking move, etc. Well, you can read, but I think it'll sound even better if I read it. In our search for the solutions to the problems, our focus is almost exclusively on the characteristics of the children themselves. We look for sources of educational failure in their homes, their neighborhoods, their language, their cultures, even in their genes. In all our searching, we almost entirely overlook the possibility that what happens within schools might contribute to unequal educational opportunities and outcomes. Okay. Now, this is a big topic, and this influences the classroom radically. I'm just going to say two things, just put it, and I'll say at the bottom there, I'm now flashed, and the same thing about teachers. So maybe I will not say it hard enough, but I'm basically saying we should stop blaming the teachers and that we as mathematics educators and mathematics teacher trainers, if you like, should bear much of a responsibility in the courses that we present, and I include a broad spectrum of people in that, meaning pre-service and in-service teachers. I think we have a grave responsibility. The 2 points I want to push is tracking, streaming, ability grouping is a no-no. According to most of this, I checked on a summary in the Encyclopedia of Math Education by Joe Bowler before I wrote that down. So I have no doubt about the research. That influences children, and that influences their attitude towards mathematics. And I add another thing, and that is extrinsic motivation and rewards. I do not know how we do not can get rid of this forever extrinsic motivation. And it's there in our classroom. Remember that it says what happens in our classroom. So who can finish first? Who's got the most right? Who's the fastest? And all this non-stop every day we reward extrinsic factors and not intrinsic motivation for love of the subject itself, etc. I decided to, so I deleted several now, I don't want to go over time. I decided to show a few light examples of how children's beliefs influence their mathematics learning. Okay, so the first one comes from, I was in a grade 1 classroom, as you know, they have a math there, and they had 2 dice, and they were tossing the dice. You all know the game, of course, was who can first say what's the answer. Quickest of the 2 top numbers. Throw it again. I said, can I work with the children for a moment? And I said, but I'm going to take only 1 dice. So I threw it, falls on a 2. So I asked the little group, so what number is at the bottom? Well, first of all, you must not underestimate our little grade 1s. They are intellectual giants. So, this one little guy got up and he craned his neck around like that. Logic. The damn thing's got 6 sides. If he can walk around, he can see 5 of them from 1 to 6. So, no problem. You can say which one is at the bottom. Must I explain again? You got it? Okay. Well, I said, no, nothing of that. So, we must just look at the top number. Can you then tell me what's at the bottom? And so I stood up to the board and I wrote, make it top and bottom. If there's a 2 on top, we turned it around, we checked, it's a 5, I wrote a 5. I throw it again, it lands on a 4. We talk, we turn it around, I write, there's a 3. I throw it again, it lands on a 1, I turn it around, it's a 6. Okay, I think after that, maybe I did a few more, but I cleared the board. And I said, okay, now I'm going to throw again. Now, can you tell me what is it? Now, I just want to share that, to my mind, even in this small little group, there were 3 distinct learning attitudes. Yeah. The first one I call it's magic. You throw the 3 and you say, what's there? And they go like this. They say, 4. You know, it's just your guess is as good as mine. Wow, it's magic. Can you believe it? So magic. The second kind is little guys sat here and they frowned like this. They were trying to remember, because we did throw a 3 just now. If you could remember what it was just now, then you're in the pound seats. And let's face it, it's actually not very difficult because there are only 3 pairs, and so many of them were quite successful in remembering, but others didn't concentrate hard enough to remember. Okay, of course, I'm going overboard with it. And then there were the last group who were all smiles and not frowning, not thinking it's magic. And what did they do? Well, when I throw this next one, what they did was to see a pattern in the table that we made. Okay? And so when we ask what is 3, they don't have to do anything. They just say 3 plus what is 7. And they make the answer. Everybody got this? Okay. And I throw again, it falls on 6. And they just say 6 and 1 is, what is 7? Answer 1. I hope you get my idea. So I'm not saying good or bad, I'm saying here in grade 1, these children have totally different learning experiences from this simple little situation that I'm sketching to you. Plain to my mind because of their personal view of what it means to do mathematics or to learn mathematics. Okay. Let me see what else. Okay, here is a second example. That was grade 1. This is like it was in the primary school somewhere. I'm not saying it's a good activity or a bad activity, but I sat next to a group and the teacher had this activity. This is not a whole activity. I'm just flashing it up there. It had 20 rows like this. And they worked through it very easily and very quickly. And I sat there at the back next to the group. And when they finished, I asked the boy next to me, so what did you learn? And he sort of jerked upwards like this. And he didn't say anything, but his body language was sort of, what does this man mean? What did you learn? You know, can't he see we just did 40 sums right? Okay? They did, there were 40 lines. There's a walkover. They did everything. Poof, 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 sat around, folded their arms, looked around. Now I ask, what did you learn? Yeah. Well, guys, what do you say? Well, it's not a in-service course. Anything to learn here? So, shall I ask what's the pattern? I made sure that I don't make a special cases pattern. Well, they didn't even, to my mind, notice that you would multiply and divide by the same number, 2 times 7, and then divide by 7. At the bottom, 9 times 8, divide by 8. So you could have said the same number. But the big pattern really is, I now jump, it's not important, it's just the moral of the story, is that the only pattern really here is that the first number and the last number is always the same. You got that? Okay. Well, what we have here then is really understanding of what inverses are all about. Divide by 7 is the inverse of multiplying by 7. So if you multiply by 7 and then divide by 7, then you have by multiplying by 1, that means it leaves it unchanged. There you have it. We could have learned something about, so some people say